first up to the stage, we have Mohammad Khasawinah. Let's come on up and give you your microphone. That's on. Do a microphone check for me.
Yep.
All right. And once you see it go full screen, that's when your 15 seconds start.
Hello, thanks James for the introduction. I'll be speaking about integration environments, but before I get into that, let's look at the problem we're trying to solve. Regardless of branching strategies that are used, a common work stream that most of us are used to seeing might look something like this, where essentially you have a main line of development in which development teams are routinely branching off of into remote branches for future development. The remote feature branches are worked on and eventually reach a point of near completion. And so a PR is born. Your colleagues take it upon themselves to review your work and speculate about it. Some may actually load it into their local runtime to provide their input. Eventually, this leads back to a merge into the main line of development, which triggers a build and deploy to a formal dedicated integration environment, which where a suite of tests are executed. It's not until this stage that your dev team gets additional feedback about that initial commit. So if there are any defects, they've already been leaked into your main line, and so you end up with a broken pipeline as a result of the extended feedback loop. Your main line is in a reasonable state, so shipping is delayed, and your development team loses productivity as a result. So let's take another look at this work stream. Why not integrate earlier in the process? Why not apply the same concept of a disposable development environment to your integration stack? Why can't we make them as easily reproducible as those development sandboxes we've grown to love? So this time around, a PR is born again, only this time it's live. We now have a disposable integration environment created on demand, and we're now able to run that suite of tests earlier in the process, shortening the feedback cycle. But that's not all. This also enables us to bring other stakeholders into the loop earlier in the process, such as designers and analysts, and other non-developers that can interact with your app and provide immediate feedback. So how can we accomplish this? There's a number of tools out there that would enable us to do this, how to go about selecting which ones are right for your organization. Of course, it helps to nail down some objectives. Speed was an important factor for us. We wanted our solution to be quick. We didn't want to create any additional bottlenecks. So self-serviceability was also another key objective. So automation became key, and we wanted these goals to be attainable. So we wanted a solution that wouldn't require significant changes to our existing CI workflow. And so we ended up with a stack similar to this for generating mostly baked images with Packer at the root. Packer was the best candidate for us since it offered platform-wide support in generating repeatable machine images. They also have an active dev community, so that was also very useful. This enabled us to build the CI pipeline you see here to generate flavored images. So we were able to generate machine images for our integration environment as well as our development environments with one stone. We also wanted to avoid any expensive infrastructure changes and lengthy setup costs. So it made the most sense to offload as much from our own servers as possible. And Packer allowed us to do this simply through a Packer push to send the workload of generating machine images and the management of artifact to the Atlas suite. We also wanted to cut down maintenance costs and shorten feedback cycles wherever possible, so it made sense to centralize management of build tools in an executable Docker container, also generated through a Packer template. And once we have that machine image, well, we need to stitch it all together. Again, our CI system comes into the act here, so CI system comes into the act, and we're testing, it's either triggered by a repository event or someone clicking a button. So we're testing integration here, so it's important that we do a pre-merge with the main line against a remote branch before kicking off a build test cycle in complete isolation in those portable Docker containers we created earlier. And given Vagrant's ability to manage many different types of machines along with a standard syntax that we were all familiar with in the Vagrant AWS plugin, launching an integration environment was as simple as running Vagrant up. So now we have a fully tangible environment created on demand that everyone can interact with, including your CI. And the best part about it is once we're done, we can just toss it out and complete the merge back to the main line. And so do we have to gain through all this? Well, let's take a look. We now have a shorter feedback loop as a result. Eventually, this leads to reduced shipping times and more productive teams and just happier teams overall, and fewer defects coming into your main line. This could have been accomplished in a number of ways. All that matters is you pick the tools that are right for your organization. Doing so, you empower your teams to be more experimental, and the shared ownership helps in fostering a better working culture. Thank you.
Billy,